let's practice with the techniques we've learned so far, because I know it's a lot. So let's find the Laplace transform of the function g, where g is in terms of jumps. So what the picture looks like is as follows. Again, this is t. That's the t. And you start at 1 until t is 5. And then the function becomes linear. So t minus 4 until 10, where the value is 6. So this is 6, and that would be t minus 4. So that is g of t. And what we have to do, we have to write g in terms of step functions, the Heaviside functions, and then take Laplace transforms. So step 1. Write g in terms of UC. See? So you start at 1. 1. And then at t equals 5, how much do you jump by? So you jump by, it's always end minus start. So the end value is t minus 4. The starting value is 1. So in this case, t minus 4 minus 1. So end minus start, which becomes t minus 5. So here really jumping by t minus 5. And at 10, you do the same thing. So you jump by, so the end value is 6. The start value is t minus 4. And so this becomes, I think, 6 minus t plus 4, which is 10 minus t. But you'll see very soon, it's useful to write this in terms of t minus 10. So this becomes minus t minus 10. So to complete that picture, here we also have a minus t minus 10. So once again, you start at 1, then you jump by t minus 5 at 5, and you jump by minus t minus 10 at 10. And therefore, g is 1 plus t minus 5, u5 of t, and minus t minus 10, u10 of t. So we wrote g in terms of jumps, and now we need to find Laplace transform. So once again, take the L. Laplace. And I would like to remind you of the formula we just covered. So if you take the Laplace transform of shift and jump, so shift and jump, it's the Laplace transform of the unshifted version, but with an extra exponential term. So once again, if you shift and jump, there's an e term that comes out. So let's apply this here. So Laplace transform of g now becomes Laplace transform of 1 plus Laplace transform of t minus 5, u5 of t, minus Laplace of t minus 10, u10 of t. Well, Laplace of 1, remember it's 1 over s. And Here, what do? We take the function t and shift it by 5 units and jump. So there is an extra exponential term that comes out. So plus e of minus 5s, Laplace transform of t, minus e of minus 10s, Laplace transform of t. Again, Laplace of shift and jump is exponential term and unshifted transform. And then this becomes 1 over s, and then e of minus 5s. Remember, Laplace of t to the n is n factorial over s to the n plus 1. So here 1 factorial over s squared minus e of minus 10s, 1 factorial over s squared. Squared. So what this becomes, this is 1 over s plus e of minus 5s over s squared minus e of minus 10s over s squared. And here you would get full credit if you just write this, but you will see soon in our ODE applications, it's useful to factor out this 1 over s squared. So this becomes 1 over s squared times e of minus 5s minus e of minus 10s.